Points, lines, and planes. Our objective is to understand basic terms of geometry, apply and use basic postulates, and draw and label basic terms. So let's get started with some terminology. A point is a location that has no size, represented by a small dot, and is named by a capital letter, like point M, point O, and point X. Space, set of all points in 3 dimensions. Line, a series of points that extends in 2 opposite directions without end. A way to write a line is line CD, or we use the capital letters of the point with a line symbol on top, or a single lowercase letter, like lowercase g. Collinear points. Points that lie on the same line. Points M, N, and O are collinear. However, points M, N, and P are not collinear. They're not on the same line. Example 1, Part A. Are points A, B, and C collinear? Part B. Are points E, F, and Z collinear? Pause the video and give it a shot. The answer for Part A is yes, they lie on line T. For Part B, no, they do not lie on the same line, as you can see. Okay, hope that makes sense. Plane. A flat surface with no thickness. It contains many points and lines without end, named by a capital letter, typically cursive, or 3 non-collinear points. Plane M, plane XYZ, or plane P in this case. Coplanar. Points and lines that lie on the same plane. 3 points are always coplanar. Example 2. A cheese cube, such as the one to the right, has 6 sides. Use 3 non-collinear points to name the plane represented by the bottom side, the plane represented by the left side, and a plane that cuts the cube diagonally. Pause. Okay, so I'll shade in blue the bottom side, and we can call this plane QTS, TSR, RQT, or STQ. The plane on the left I'm going to shade in red, and I can call this plane MNT, or QTN, or QNM, or TMQ. There's a couple of combinations here. And then the diagonal one, part C, there are many possibilities here. I'll try a green diagonal and an orange one and a purple one. You can see the different possibilities for the diagonals, as well as the 3 non-collinear points that you need to use to label a plane. Okay, I need to give you some vocabulary now that you're going to see a lot. Postulate, axiom. Basic rule of geometry, an accepted statement of fact. Theorem, a statement that can be proven true using other postulates and other proven theorems. So let's take a look at some postulates from this section. Through any 2 points, there is exactly one line. Line G is the only line that passes through points C and D. Through any 3 non-collinear points, there is exactly one plane. Points X, Y, and Z do not lie on the same line, therefore are on one distinct plane, plane P. You might want to pause this before we move on because we have a couple more postulates coming. If 2 lines intersect, they intersect at exactly one point. We've seen that in algebra. Line XZ and line WU intersect at point Y. If 2 planes intersect, they intersect at exactly one line. Plane ABF and plane ABG intersect at line AB. Example 3. List 2 other ways to name plane Q. List 2 other ways to name line F. Are points M and C collinear? Are they coplanar? Are B, C, and X coplanar? Is plane XYZ a good way to label a plane? Pause. Okay, let's take a look at the answers. We need 3 non-collinear points for part A, so we could use plane MXY or plane BMX. Part B, 2 other ways to name line F, line XY, line XZ, line ZY, for example. Part C, M and C are collinear and coplanar. There is one distinct line through M and C. However, there are infinite planes through M and C. Part D, yes, any 3 points are coplanar, so that'll work. And part E, no it is not. A plane cannot be named with 3 collinear points. Infinite planes pass through X, Y, and Z. Well, okay, that's it. Hope you enjoyed this presentation.